Alright, we are continuing our journey with logarithms. Today we are going to be evaluating logs and exponentials. So the first skill we're going to practice is going back and forth between log form and exponential form, because again, logs and exponentials are inverses of each other. So if I have a log, y equals log base a of x, that is equivalent to x equals a to the y. So your bases stay the same. For your log, the number that was by itself becomes your exponent, and what you're evaluating the log at moves to be solo in your exponential equation. So we're going to practice doing that back and forth a few times. Starting on this first one, we are just going to rewrite each of these as exponentials. So the base of my log on a is 4. The number by itself is my exponent, and that's equal to the only other number I haven't used yet. Now with these, it's a lot easier to determine if we've done this correctly, because I can look at this equation and say, is this a true statement or not? If I had arranged those numbers in any other way, I would have a false statement and I would know I had done something wrong. But 4 to the 4th is indeed 256. So on to the next one. 4 to the negative 2 is 1 over 16. Again, that's a true statement. On C, 36 to the 1/2. Remember, that's the same thing as square root, is equal to 6. Once again, true statement. Now we're going to do it the other way around. We're going to go from exponential to log form. So the base here is 3, so I'm going to have log base 3. My exponent's negative 2, so that goes over here by itself, and I'm evaluating 1/9. On B, my base is 5. My exponent is 4, and I'm evaluating it at 625. Last one, my log base is 25, my exponent is negative 1/2, and I'm evaluating that at 1/5. So why is this handy? Because that is how we can solve log equations. So we're going to rewrite it as an exponential equation and solve. So on this first one, this is going to be 3 to the 3rd equals x plus 5. 3 to the 3rd is 27. So I just need to subtract 5 on both sides, and I find that x is 22. On the next one, this is 2 to the 4th equals 2x plus 7. So 16 is 2x plus 7. So first I have to subtract 7, then divide by 2. X is 9 over 2. Excuse me. On C, 36 to the 1/2 is equal to x. Remember, 1/2 power is the same thing as square root. So x is 6. Next one, 10 to the negative 2 is x. So that's the same thing as 1 over 10 squared, which is 1 over 100. And then 8 to the 1/3 equals 5x. Cube root of 8 is 2. So I just have to divide by 5. And there are my values of x. And then just again practicing using the buttons on the calculator. If I want to evaluate these two logs, when there's not a base written, we assume it's 10. So I can use the log button that's on my home page of the calculator right here next to the number 7. So if I want the log of 5, I can just type in log 5. And for most of these, we're going to round to 3 decimal points. Same thing for log of 2.7. Just going to round to 3 decimal places. And then we are going to continue talking about logs, but we are going to take one slight detour to talk about a special type of exponential function, and that is our natural exponential, when we have our natural base e. E is kind of like pi in that it's a special number that repeats and goes on forever, and it's approximately 2.7. It looks like a normal exponential function. You know, our domain is all real numbers, our range is all positives. We've got a y-intercept at 0, 1. It's increasing, and we have that horizontal asymptote at y equals 0. And this is the approximation for the value of e. Now, where do we use e in math and in real life? Well, with interest. So, quick example, if I have compounding interest in an account, this is the formula I would use, where p is my principal, the amount I invested, r is my interest rate as a decimal, n is the number of times I'm compounding per year, and t is time in years. So just for quick example, if I invest $15,000 at 8%, the balance after 6 years, if I am compounding quarterly, that means n is 4 4 times per year. So that value would be 15,000 times 1 plus 0.08 over 4 to the 4 times 6 power. You can just type that in your calculator, and the value you are going to get is $24,126.56. Then say I compound monthly instead. That is 12 times a year. So I'm using the same formula, but instead of n being 4, n is going to be 12. And again, I'm going to type that into my calculator, and I get $24,202.53. So the more I compound, the quicker that my investment is growing. So if I can have continuously compounding interest, that is even more desirable to me. And so we have to use this special formula for compounding interest continually with our special E. And I'm going to show you where that is in your calculator. So for that, it would be 15,000 times E to the 0.08 times 6 power. And we use our calculator for this. So your E button is right here above ln, which we are going to also talk about here in just a moment. And so to get that, you hit second and then ln. So to calculate this, that's 15,000. Again, second E to the 0.08 times 6 power. And so it has grown even quicker. So why do we suddenly care about E? What does it matter? Well, because E being a special natural base, when we have logs for E, it also has a special log called the natural log, or ln. That is an L, not an I. Ln is a log with your base E. So if you are taking the log of E, you have to use natural log, and if you're using a natural log, that means your base is E. So just like with the logs on the front page, we can go from exponential to logarithmic and vice versa. Let's practice that first. Ln of x plus 2 equals 6. That means e to the 6th power is x plus 2. On B, this means e to the x plus 2 is equal to 1 over 16. C, e to the 1/2 power is 2x minus 5. Now let's do it the other way. E to the negative 2 equals x. That means the natural log of x equals negative 2. If e to the 4x is 2, that means the natural log of 2 equals 4x. And then on this last one, the natural log of 5 plus x is going to be negative 1/2. We can also solve log equations with natural logs. Again, we want to convert it to an exponential, but first, if there's stuff surrounding it, I have to use algebra to get the log alone. So on this first example, I need the natural log of 6x minus 6 to be by itself. So I'm going to add the 14 first. And then I can divide by 4. So the natural log of 6x minus 6 equals negative 2. The log is now by itself, so I can rewrite this as an exponential. This is going to be e to the negative 2 equals 6x minus 6. And I can find out what e to the negative 2 is in my calculator. I'm going to hit second e to the negative 2. And so that's about 0.135. And if that is 6x minus 6, to find x, I'm just going to add 6 and divide by 6. And x is approximately 1.023. Let's do that again. I need to get the natural log by itself, so I'm going to subtract 12. And then divide by 6. Now I can rewrite it as an exponential. I can find e to the negative 3 in my calculator. Then to solve for x, I'm going to add 7 and divide by 3. Okay, and then again, if I have logs that are not exact, I can still evaluate them in the calculator by pressing my ln button. It's right here below log base 10. So if I want the natural log of 5, can type that in the calculator, or the natural log of 2.7. Again, type it in the calculator. The last thing we're going to do is solve some exponentials. Similar to solving logs, you first need to get it by itself, then you're going to rewrite it as a log equation and solve. So here on A, 3 to the x is my exponential, so I need to divide the 605 to get it alone. I am going to leave this as a fraction, and it does reduce to 1 over 11. So if 3 to the x is 1 over 11, when I rewrite that as a log, that's going to be log base 3 of 1 over 11 equals x. Well, I can find log base 3 of 1 over 11 in my calculator. Again, going math, alpha a when my base is not 10. And there is my x. On B, my exponential is already alone, and my base is 10, so the log of 19 is going to be equal to x, so less buttons I have to push for that one. And x is approximately 1.279. Last one, my exponential is alone, so this is going to be log base 12 of 62 equals 2 plus x over 4. So to find log base 12 of 62, it's going to be about 1.661, and what I have to do with that value is subtract 2 and multiply by 4 to get that x is about negative 1.356. And then we are not going to do that back page today. This is something that you also use logs and exponentials for. It's word problems where you have to find a and b using context, but we are just going to skip out on that for today. So that wraps up our notes on day 2 with logs and exponentials.